Have you ever wondered how a small person can lift a heavy rock with just a stick? This fascinating phenomenon is all thanks to simple machines, particularly levers. In the next few minutes, we'll explore how levers work and why they are such powerful tools in our everyday lives. Levers are one of the 6 classical simple machines, which also include pulleys, inclined planes, wedges, screws, and wheels and axles. A lever consists of a rigid bar that pivots around a fixed point known as the fulcrum. When force is applied at one end of the lever, it can lift a load at the other end, effectively multiplying the force exerted. This principle is rooted in physics, specifically in the laws of moments and torque. Now, let's dive into some interesting points about levers. First, the position of the fulcrum is crucial. By moving the fulcrum closer to the load, you can lift heavier objects with less effort. For example, think about how a seesaw works. If one child sits closer to the center, while the other sits further out, the child further from the fulcrum can lift the other with less force. Second, levers come in 3 different classes, each defined by the relative positions of the load, effort, and fulcrum. In a first-class lever, like a seesaw, the fulcrum is in the middle. In a second-class lever, like a wheelbarrow, the load is in the middle, and in a third-class lever, like a pair of tweezers, the effort is applied between the load and the fulcrum. Each class has its own advantages depending on the task at hand. Third, levers are not just found in playgrounds, they are everywhere in our daily lives. From the simple act of using a crowbar to lift a heavy object to the complex mechanisms in machinery, levers help us perform tasks more efficiently. They reduce the amount of force needed, making it easier for us to accomplish work that would otherwise be too strenuous. Lastly, the concept of mechanical advantage is key. This is the ratio of the output force produced by the lever to the input force applied. A lever with a longer arm will give you a greater mechanical advantage, allowing you to lift heavier loads with less effort. This principle is not only applicable to levers, but also to other simple machines, showcasing the interconnectedness of these tools in physics. In summary, levers are a remarkable example of how simple machines can multiply force and make our lives easier. By understanding how they work, we can appreciate the ingenuity behind everyday tools and the fundamental principles of physics that govern them. So next time you see a lever in action, remember the incredible power of this simple machine and how it helps us lift the weight of the world, one small effort at a time.